Hello, for our very first content video, we're going to look at equations. So I have been saying that the topic of this course will be going to be covering ODEs and PDEs, but those are just acronyms and we haven't really looked at what they mean. So let's first look at what possible equations we can handle. So I expect you to be fairly familiar with algebraic equations. Those are the standard equations, the equations we are most comfortable with usually. With algebraic equations, we just mean equations like x plus 3 equal to 0, or things of this sort. So they're all equations that we have been looking at since pretty much elementary school. We can solve things like x squared plus 4x minus 3 equal to 0, and for things of this sort. I expect you to be fairly comfortable with algebraic equations as far as possible. By the way, next video is going to be concentrating a little bit on them, just to have an overview of what is possible and what is not. So after that, we have ODEs and PDEs. Their acronym stands for ordinary differential equations and partial differential equations. Now the concept is fairly different from the idea of algebraic equations. In algebraic equations, what we don't know, it's written as x and it's a value. We're looking for the value satisfying the given equation. In ordinary differential equations and in partial differential equations, we're not looking for one single value anymore. We're looking for a function that satisfies our constraints. So let's have a look, for example, at the function f that takes values x. And I want it to satisfy some given restrictions. As I will formulate the restrictions, I will formulate them as restrictions on its derivatives. So, for example, I can ask f such that the first derivative of f is equal to 0. Now, this is a constant function. I can also construct things that are more complicated, like I want the first derivative of f plus twice the second derivative of f to be equal to 0. And I can keep getting more and more complicated structures. The more complicated the structures, the more restrictions there will be on the function itself. For example, if I only have information on the first derivative, then I'm not requiring the second derivative to exist. While if I have information both on the first and on the second derivative, that means they're both existing. So our first section of the course will be looking into ordinary differential equations and how to solve them. And we'll always be looking for a function of one variable. It can be f of x, or sometimes mathematicians like, because we're complicated people, looking at x of t. In this case, we're considering a position of a particle that changes over time. T is the time and x is its position, and we know something about how the position is changing over time. And then we have to go to partial differential equations. Partial differential equations means we are taking partial derivatives. But to take partial derivatives, it means that we're looking at a function of multiple variables. So while in ODEs we're looking for f of x, in PDEs we'll be looking for f that depends on multiple variables. So x, y, z, and possibly even more variables. But let's stop at 3 dimensions. That is something we're usually comfortable with. Partial differential equations are about giving constraints on the derivative of f of x, y, and z. So I would have something like derivative with respect to of x of f at x, y, and z plus derivative over z of the derivative over y of f at x, y, and z equals to 0. And again, as in the case of ordinary differential equations, I can compose all these derivatives and make very complicated problems that we'll try to look at when we will be looking at partial differential equations.